A jar is filled with 63 different colored marbles, 11 which are red, 25 of which are blue, and 27 of which are green. A player is asked to draw a single marble from the jar, and if they draw a red marble, they will win $20. If they draw a blue marble, they will lose $10, and if they draw a green marble, they will lose $5. You may round your answer to the nearest cent. So what is the expected outcome of this game? So the expected outcome is another way of asking for the mean of the distribution. So the mean of the distribution we can get by using the calculator and putting the different outcomes that are possible into L1 along with the probabilities that are associated with each. But there's sort of a problem in this case because the different outcomes, we have that someone could draw a red marble, someone could draw a blue marble, or a green marble. And so the situation is that the outcomes are qualitative and not quantitative. But we can encode that information in terms of how much the person would gain if they drew each of these kinds of marbles. So if a red marble is drawn, they win $20. If a blue marble is drawn, then they lose $10. And a green marble is drawn will cost them $5. So then the probability of each of these, well, there's 63 different colored marbles, 11 of which are red, so 11 over 63 chance of getting that marble that will win you some money. But there's a 25 over 63 chance of getting the blue one, and a 27 over 63 chance of getting the green one. What is the expected outcome of this game? So the expected outcome, we will list the different outcomes as their gains. And that will go into L1. Probabilities always go into L2 when we do the one-var stats program. So let's start putting our information into the calculator. So go into the list editor first. If you have anything in the list editor, clear it out. 20, -10, and -5 are my outcomes. The probabilities, it's actually okay to put 11 over 63 as your probability because the calculator will compute what that value is before entering it into the list. And the nice thing about that is you have more decimal places than you would if you had done the operation yourself and then copied the answer in, and just giving you a more accurate result at the end. So 25 over 63 and 27 over 63. Now, if we run one-var stats, taking care to make sure we use weighted statistics, and the way it knows that is if we give it both parameters L1, L2, and the expected outcome of this game is the mean, which is -2.62. Which means over time, we can expect to lose $2.62 every single time we play. Which means this would not be very profitable to play over time.